Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through applications of linear functions. So this will involve a worded problem where we find an equation and then draw a graph. So let's look at an example. Let's look at this example here. Tank contains 900 litres of water, 30 litres is leaking out of it each hour, and we will represent this with a graph and use it to find how long it will take the water level to be below 300 litres. So I'm going to start by writing an equation. So I'm going to turn this information in black into an equation. So I want an equation that links the two variables here, the volume of water I'm going to call V, the amount of water in the tank, and I also have the variable T, the amount of time that's passed. So because it talked about 30 litres per hour, I'm going to let T be the number of hours. So the equation is the amount of water, the volume, is 900 litres minus 30 litres per hour, 30 times the number of hours. So it wouldn't matter if I use different letters than V or T. Usually I use Y or X, but it doesn't matter too much. What we need to know is when we have worded problems like this, we want the independent variable along the horizontal axis. So we want the independent variable along the x-axis and the dependent along the y-axis. So here, the independent variable is time. The time doesn't depend on how much water is leaking. Time just keeps going on no matter how much water is leaking. But the amount of water in the tank, the volume, depends on the amount of time. The amount that moves out of the tank is limited by how much time has passed. So Y, the Y variable, in this case the volume, is dependent on time, and X variable, which is T, the number of hours, is the independent variable, because it doesn't depend on anything else. So we're going to put the time, whether I call it X, T, A, whatever, I'm going to put that along the horizontal axis, and I'm going to put the volume along the vertical axis. So let's draw up a Cartesian plane. Of course, I only need the first quadrant because I can't have a negative amount of water in the tank, and I'm not going to worry about negative time. So I'm going to mark my axis. So I have the x-axis, which is time, and I'm going to have my y-axis here, which is the volume. So the volume needs to go up to 900. So of course I'm not going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to go up by a different amount. So in this case, I'm going to choose to go up in hundreds. So I've labeled my y-axis. So this is the volume in litres. So how do I actually draw the line? So there's a couple of ways. We've gone through table of values and the XY intercept method. So I'm going to use the intercept method for this because I just think it's a lot quicker than drawing up a table of values. So this is my equation here. So I can write that as y equals 900 minus 30x. I can change the v to a y and the t to an x. So remember to find the intercepts. So the y-intercept occurs when x is 0. So then I would get y equals 900 minus 30 times 0, so just 900. The x-intercept, that comes about when y equals 0. So if y equals 0, I get 0 equals 900 minus 30x. Subtract 900 from both sides. You know how to solve equations. So I get minus 900 equals minus 30x. Divide each side by not 30, minus 30, I get 30 equals x. So this will be a straight line, and it will have y-intercept of 900, x-intercept of 30. So I'm going to draw up my x-axis. I need to go up to 30. So I just want us to be clear, the reason this is a linear function is because each time t increases by 1, each time the x variable increases by 1, y, or volume, decreases by the same amount. It decreases by 30 each time. So this one has a gradient of negative 30. So I'm just going to rule up my x values now. So again, I'm not going to go up by 1. I've chosen to go up by 4. You can choose to go up by 2s or whatever. So x is obviously the time, and we need to stipulate that that is in hours. So now that I've found the two intercepts, it's easy as to graph. So the y-intercept is going to be 900, which is there. The x-intercept is going to be 30, which is there. So it doesn't matter that I've gone up by a different amount each time on the axis, that I went up by 100 each time on the y-axis and by 2 each time on the x-axis. That doesn't matter. So I've got my two intercepts. I'm just going to join them up. So I just join them up like this. So that is the line. I don't need to put arrows on this one because it's not going forever, because it won't keep losing water after it's empty. So I want to know how long it will take until the water level is below 300 litres. Well, 300 litres is this line here. So if I go across like that, that there is 300 litres. So you can see that that 300 litres occurs here, and that occurs after 20 hours. And after 20 hours, you can see the volume here is clearly lower than this line. It's clearly lower than 300 litres. So the answer to that, how long will it take until the water level is below 300 litres? 20 hours. And we just got that from the graph. All right, I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.